Good morning everyone, and good morning online kids as well. Okay, today we are discussing 2014 paper. All the way we missed a couple of papers from 2000 to 2010, but after 2010 continuously we came to 2014 paper. Every week I do, once I done this class, every week I do the instruction for the next paper. Just remember, it's not you are just writing, let's say 2-hour paper plus 3-hour paper, 2 hours 50 MCQs, 3 hours for structure design for essay. It's not the part, that actually is the rough idea, but when you are going with paper by paper, you are getting your improvement, then you are practicing and you are improving your own tactics. How would you do the next paper? So that if you are going to another class or if you are getting instruction from somebody else, that's okay. Otherwise, contact me. Especially these online kids, I know you guys are not contact me like enough. If you couldn't get this recording, contact me, because every week once I'm done this paper, I'm going to, I would do this recording for how you would do the next paper. If you are not coming to the class physically, please you're supposed to have that instructions. Okay, because for 2014 I've already posted. And then again, if you talk about this 2014 paper, if you go with all papers from 2000 to, okay, 2014 is the paper that students got least marks. If you go from 2000 to 2025, so let's see what are the difficulties of this paper. This is some sort of a very difficult paper, and at the same time you are doing this 2014 chemistry paper. At the same time, do this 2014 physics paper, that as well is also really challenging paper. Okay, Bayan, my 2025 district first Island 6, he got for physics, he got I guess 47 out of 50, 47 out of 50. Chemistry is always marks are higher. Anyway, so that this is the thing about the 2014 paper. Okay, let's go with these MCQ answers. Question number 1, answer 3, 2, answer 5, 3, answer 2, 4, answer 5, 5, answer 4, 6, answer 2, 7, answer 2, 8, answer 3, 9, answer 1, 10, answer 2, 11, answer 4, 12, answer 3, 13, answer 2, 14, answer 3, 15, answer 4, 16, answer 3, 17, answer 2, 18, answer 3, 19, answer 2, 20, answer 3, 21, answer all, 21 all, 22, answer 3, 23, answer 2, 24, answer 2, 25, answer 3, 26, answer 5, 27, answer 2, 28, answer 2, 29, answer 1, 30, answer 4, 31, answer 5, 32, answer 4, 33, answer 3, 34, answer 1, 35, answer 4, 36, answer 5, 37, answer 4, 38, answer 1, 39, answer 1, 40, answer 5, 41, answer 4, 42, answer 1, 43, answer 4, 44, answer 1, 45, answer 4, 46, answer 4, 47, answer 5, 48, 2 answers, 48, 305, 305, 49, answer 3, 50, answer 5. Alright. Okay. Since you are reaching more and more closer to modern papers, now whenever I'm explaining this paper, me to convince you guys the answers, and it's easy for you guys to get answers. And remember, when you are moving forward, so the balancing is now better. See, more questions are coming from unit 2 and 6, and then organic, and then equilibrium. So the contribution from the other other units are very, very low. You guys can see now the contributions from all the other units are really, really lower. So this is a well-balanced paper. Major marks are coming from organic, inorganic, equilibrium plus unit 2. So as we discussed earlier, if you guys went through nicely with all these 4 papers, you can do this really nicely. And then the last week, I just want to know like how these students are doing. For 2027 students, I've given 2012 paper. They reached like 33, 34 marks. 2027, now they are at the beginning of organic. Beginning means only they have done the nomenclature. But they reached up to 34, 30, 30, 32. There were a couple of students. Marks were like really good. I was really happy, and they were like, if this kind of a paper is the final paper, we can do this really nicely. That's what they said. Then I said, yeah, exactly same style you guys are managing. You guys only need the practice to reach 100 out of 100. Reaching this kind of marks is really, really easy, but reaching 100 is difficult. Again, before I start this one, I would say, now you guys have done your paper, you guys have the best memory. I'm doing this recording to students who's trying to reach B or A passes. These recordings are not for weaker students who's trying to reach S or C passes, because I'm not explaining each and every single detail. When I'm explaining very, very simpler details, then the students who work really well, they will feel frustrating. They will feel it's waste of time. I know you guys, how much you guys are efficiently using your time. So that makes sure you guys have to read questions and you have write written answers. If you still feel something wrong, I'm just giving support for that. So that make sure whenever, and the other thing, when you're going through these answers, whatever the thinking style, okay, like you guys have the full theory knowledge, but still you guys are doing mistakes. So make sure, improve your thinking style listening to me. Listening to me, you guys have to improve your thinking style. Okay, let's go one by one. Question number 1. The neutron was discovered by James Chadwick. James Chadwick. Okay, I have written all the other information, but I don't think you guys do not need that. So the question number 1 answer, 3 James Chadwick. And then question number 2, they are asking the group of this element. Okay, so they were given one negative value here. Let's say that is a resultant negative value. If I give negative value, see, you guys can see all these 3 are single bonds. Then they are supposed to be 3 negative values. So that to get one negative value out, they are supposed to be +2 charge on middle or central atom. On middle or central atom. Okay, so all together then you have 1, 2, 3, 4, 5 here, but with +2 charge it's 7, so that this belongs to group 17. Question number 2, answer 5. Question number 3, answer 2. Question number 4, maximum number of electrons having quantum number n equals to 3, l equals to 2. You can go with any method. L equals to 2 mean just the sub-energy level. So the sub-energy level has 5d orbitals, so that each has 2 electrons, so it is 10, or 2 into 2l plus 1, whatsoever. There are a couple of methods always. We did all those theory. Question number 4, answer 5. Question number 5, highest melting point. So the dipole moment is 0, so all those are non-polar. Then through the London forces, molar mass highest is xenon. Question number 5, answer 4. Question number 6. What mass of sodium chloride would contain the same total number of ions in Magnesium chloride 285. Let's see how many ions in magnesium chloride 285. 285 divided the molar mass of the magnesium chloride, that is 3 moles. So that since the stoichiometric ratio is 1 is to 2, magnesium supposed to give, magnesium 2 plus 3 moles and chloride 6 moles, altogether 9 moles. And then if you go with sodium chloride, it only gives 1 and 1 here, so 2 moles. Okay, so if you divide 9 by 2, that is 4.5 moles. Then if you have 4.5 moles, you can get same 9 moles of sodium chloride. So this is the number of moles. That multiply the molar mass. So that question number 6, answer 2. Question number 7. Again a very easy one. A solubility product is giving concentration actually, or the solubility is asking. So KSP, you don't have to write any of these. What you can do is, you know, this is one ion. So let's say that's A. You have 3 ions, then this is become 3A to the power 3. See, A into 3A to the power 3. So you can start from here, 27A to the power 4. And then equalize to this one, equalize to this one. And if you divide these two, see, you get 16, that is 2 to the power 4, that is 2. Question number 7, you can get very easily, this simplification is actually easily. Question number 7, answer 2. Question number 8, likely take place during nitration of benzene. Benzene nitration, electrophilic substitution reaction. Which one is not likely? Not likely. Wrong one is asking. Because you have carbon which joins to NO2 cannot bear a plus charge. You have plus charge here. That's why it's wrong. All the others are correct. Question number 8, answer 3. Question number 9. Equimolar mixture PCl5 gives POCl3 and 2HCl. Question number 9, answer 1. Question number 10, 6 vessel pairs, shape and electron pair geometry are respectively. Answer 2. Answer 2. Question number 11, correct with respect to isolated system. Open system can transmit matter energy. Closed system can transmit only energy. Isolated system cannot transmit both. Boundary of the system does not allow matter, heat or work to exchange. That is an isolated system. Question number 11, answer 4. Question number 12. Which one of the following statements regarding 3D element is false? Okay, online students, understand this. Like when I'm explaining this, I would just explain. But once you guys are writing your own reviewing, once we've done this for 50 MCQs, you're supposed to write your own reviewing. During that time, you guys can WhatsApp me questions. And the physical students, they can ask questions. Question number 12. Which of the following statements regarding 3D elements are false? Wrong statement is asking. Electronegativity of 3D elements generally increases across a period. Yeah. For all periods, it's same. First ionization energy of 3D elements involving removal of 4s. Yeah, because that has the lowest energy. And removal of 4s is easier because it has less electrons. The highest oxidation number for the first 5 3D is increasing 1 by 1. That's because there are less unpaired electrons. The density of 3D elements are much higher than the 3s. Yeah, because the size is smaller, mass is greater, density is greater. Melting points of 3D elements is actually always greater because 3D has d electrons and s electrons to participate for a metallic bond formation, and also the radius is less. So that metallic bond strength, electrostatic attraction, melting boiling point, sublimation, all are high. rigidity or high. Question number 12, answer 3. Question number 13, density given 18%, of this purity given, density given, molarity, concentration is asking. Okay, so that 1 cubic centimeter has 1.1 gram mass. To convert this into cubic decimeter, molarity will come with the concentration cubic decimeter. So we're going to multiply these both sides by 1000. So the mass is 1000 and 100. And then out of that, 18% is only ammonium sulfate. Then you are going with 18%. So the value is 198 grams. That is the mass per 1 cubic decimeter. Mass divided by mole mass is the number of moles. Since that number of moles is in 1 cubic decimeter, that actually is the concentration. Question number 13, answer 2. Question number 14. Standard enthalpy of combustion of carbon given. Formation values of carbon monoxide and H2O is also given. Standard enthalpy change of reaction. So they were given this reaction. The very first step is you are just writing the reaction. And then they were given the formation enthalpy because and combustion enthalpy of carbon when you can start has to start from carbon. So my common bucket, I'm just writing naturally existing constituent elements to my common bucket so that I'm going to make this carbon dioxide and this carbon monoxide and this water. All data given. Only unknown is this one. So that you have two different paths coming from here to here and all the way from here to here. Equalize those two and subtract this one. You can get the answer very easily. Question number 14, answer 3. Is again an easy one. Now you guys can see, since we did equilibrium really perfectly, getting answers for equilibrium is easier rather other units, because you have forgotten other units we done a little earlier. Since we did the equilibrium last, you can get answers very easily. Solubility product of the sparing soluble hydroxide MOH is this one. pH is asking, only little difference is this time they are asking pH, okay? Same as the last question we did. So this is a dissociation. Let's say solubility is X. So X and X, because the stoichiometric ratio here is 1:1. So you're going to write just the Kp expression, and then Kp equals to this one, which equals to X squared. See, this is the very first step you are writing. You don't have to write any of these. No point of writing these. These are MCQs. And now we are fighting for the real exam. So we are saving timing. We are still going to 2 hours and 3 hours. We didn't start to squeeze timing, because I know 2000 up to 2014 is really challenging. Then we're going to do that. After that we're going to squeeze timing. Anyway, so this one here, get the root value. That actually is 10 to the power minus 4 mean the concentration of this OH. But then they are asking pH. So that pOH equals to 4. So that pH equals to 14 minus 4. Question number 15, answer 4. Question number 16. This is a triple phase diagram of anything other than water. Actually, we did this for, this actually is for water. So other triple phase diagram, this OC goes like this. OC goes like this, positive gradient, but here we have negative gradient. So this is a triple phase diagram of water. This CO has negative slope. And they are asking the same thing, liquid and solid. Between CO, that is solid and liquid, so it's CO, OC, OC. How we see these questions? I don't know like why you guys can get enough marks. If you guys are losing marks, I lost the annotation. I lost the annotation. Why I'm keep showing this picture now? Encouraging you guys to reach like such. But still Bayans and the Island First students, result score has first, I don't remember the exact considerable difference. Because Bayan didn't study enough. He's sort of like, doesn't like to stay up. He doesn't like to kill timing. And consequences are there now. Okay, so this is the Clemmensen reduction. So the reduction, and here you have the HCl acid, so you can break this one here. With the Clemmensen reduction, this is going to CH3, and then this one breaks, so that this part is become OH, and then the other side you have C6H5COOH, and that's again after dissociation it is this. Question number 17, answer 2. Question number 18. Okay, this is again question number 18. This is again same way that we play with number of moles. Here they were given this question for us to play with pressure. The gas A dissociates at temperature T. According to the elementary reaction, N moles of gas A were kept in a rigid container and allowed to dissociate at room temperature. Initial pressure is P naught, and after the time T pressure is P. Identify which of the following terms are proportional to the rate of reaction at time T. Okay, rate asking given that pressure, so I'm going to play with pressures here. Okay, since elementary reaction, order equals to stoichiometry. Order equals to stoichiometry. Proportionate to the rate of reaction at time T asking. They're asking the rate. Okay. This time again I'm just showing this on PV equals nRT, P equals N over V RT. So that NOV equals to P equals to CRT, so that the pressure is proportional to concentration. Instead of concentration terms, I'm using pressure terms because they were given the pressure terms. Okay, so that okay, I'm going to start from here. So the initial pressures P naught. After time T, pressure is PT. So that the stoichiometric ratio here is 1:1. So that if the PT is remaining, the dissociated part become P naught minus PT. But here the stoichiometric ratio is 1:2. So this part supposed to be twice of that. And then I'm going to simplify this to get the total number of moles. So here the number of moles equals to pressure, so we are getting the total pressure. So 2P naught into 2 into PT. So that's become 2P naught minus 2PT. So the total pressure equals PA plus PB plus PC. That PT plus 2P naught minus 2PT plus P naught minus PT. So that the total pressure here is PT equals to 3P naught minus 2PT if you simplify this. And then from that, if you subject a total pressure, 2PT equals, time T, at time T, if you subject T, so PT, so that equals at the end of the day, 3P naught minus P total, then to get this 2 here, I'm going to divide by 2 here, and then get this half separated. So PT equals half into 3P naught minus PT. So that this is the partial pressure of A after time T. Partial pressure of A after time T. But if you go with the rate expression, and the rate expression is only, this is elementary and the only reactant is A, so that I can write the rate expression as R equals K into PA, and after time T, that is PT, but instead of this PT, now I'm writing this full part, half into 3P naught minus PT, and and then this k and this half, both are constant, it's not changing. So that remove this part, so that R is proportional to 3P naught minus P total, but they were given P total just as P. Here P total is P here, exactly same. They were given only the symbol P. So that question number 18, answer 3. You are just deriving equation for rate expression. This is the rate expression equation. Then you find after time t, what is the pressure here. Okay, question number 19. I told you guys, once you go through this path, once you understood everything, later, not the symbols, they are giving these real values. Remember 2013 paper, again they were given symbols, but this time they were given real values. But if you write, okay, they are asking solubility product of BR. If you write the solubility product, this is the equation. How would you get this equation? This is the reaction. How would you get this reaction using given these two equations? I have named these two equations as 1 and 2. And then if you write the backward reaction of the second one, this is T. If you write the backward reaction, equilibrium constant becomes the reciprocal, 1 over K2. And then if you add the very first reaction and then this backward reaction together, then you are reaching this KSB reaction. So it simply means 1 plus 3, we can write K1 into 1 over K2. So that is this thingy, which equals 1 into 1 over K2. Then multiply these two. Question number 19, answer 2. Question number 20. Question number 20, answer. This is very obvious, you can get answers very easily, changing the double bonds. Answer 4. No, wrong. See. Me? 1 here. You don't have to draw this. You are not drawing this one. 1 double bond here, and then you are changing these two. Clear? And then again, 1 double bond here, then you are changing these two. Got it? That's easy. Memorize that way. I don't know you have enough time to go through this all the resonance. When you go through all the resonance we did for theory. නෑනේ මෙයාට numbers දෙන්නකෝ 1 2 3 4 1 2 3 4 N1 and 2. See the double bonds are in between N1 oxygen 1, N2 oxygen 3. Okay? N1 oxygen 1, N2 oxygen 3. N1 oxygen 2, N2 oxygen 4. Totally different. Because we did this for theory. These are like very simple theory questions. Question number 20, answer 3. Question number 21, for you guys answer all. That's because for our syllabus, this older syllabus, this is the wrong answer. But this is correct answer for you guys. Which one of the following is false asking for scandium? Most stable is +3. Scandium 3 plus 4s0, 3d0. Scandium is white because there is no D1, D9. The first element, scandium is transition. For new syllabus, only zinc is non-transition. Earlier it's wrong. So for you guys, all are correct. Could you understand that? Question number 21, answer all. Question number 22. oxalic acid H2C2O4 is a dibasic acid with K1 and K2 values given. What is the equilibrium constant for the reaction given below is asking. This is actually same as that K reaction. See, you're just going to go like that. Okay, so this is the first dissociation and this is the second dissociation. The reaction they were given, this blue reaction is the addition of first and second equations. Addition of first and second. Addition means equilibrium constant are multiplying. So multiply these two. Whatever the question they are asking, see how easily you can explain the answer. Question number 22, answer 3. Question number 23. S, T and U, they are asking, with acid halides, OH goes through estratification, so you are getting OCOCH3. CHO is not changing here, and then you are adding something and then going, adding Grignard and acidifying. Then you are getting T and U by acidifying. Remember, this is the CO part. So this is the part which you are adding two identical CH3 groups. When you are adding Grignard, when you add acid, this one is breaking from here. See, this one is breaking from here. And then, see, they were like trying to confuse you. This is COCH3 part. That COCH3, see, CH3CO, that part. See, this is that part. With the Grignard, this Grignard CH3, it is joining two groups here. So that is that part. And then, this once you break this part, if I go with another color, I'm going with purple here. This part with oxygen is this part. But then again, Grignard gives one single CH3 joining here. What the answer? Yeah. So that this is the answer. When you break this one, COCH3 is the one which is going through this nucleophilic addition. You add two identical CH3 groups. Question number 23, answer 2. 24, answer 2. 25, looking at these two diagrams, to reach equilibrium, it took 100 seconds. To reach equilibrium, it has taken only less than, see, if this is 100, half is 50, so this is become 25. Okay, true statements are asking, T2, less time taken to reach equilibrium, so that T2 supposed to be greater than T1. Okay, one part has solved out, so T2 is greater than T1. And then at T2, when the temperature is increasing, A is greater. A is greater. See, A is greater means the reactant. So when temperature is increasing, if it's going to backward, so backward is supposed to be then endothermic. Forward reaction is supposed to be then exothermic. Forward is exothermic. Question number 25, answer 3. Identify the cation given. Black precipitate with H2S in the presence of OH minus, that is group 4. Cobalt or nickel. No precipitate with H2 is in DLHCl. So it simply means no group 2. Both, so that answers are cobalt and nickel. Blue solution with HCl. Nickel is yellow, so this is definitely blue. Cobalt is blue. Question number 26, answer 5. Better explanations I have written. I wasn't written the review halfway. It's like very completed reviewing. I'm not showing everything to you guys just because we don't want to waste time in here. Yeah, this is the group analysis information and everything. Aldol condensation one is down there. In my reviewing, I have written everything, but I don't want to waste time in here, like if you understood everything. Otherwise, you guys can talk to me after the class. Question number 27. Major product object reaction given below. See, inside of one single compound, they are given primary, secondary, tertiary, and all. So this is oxidizing. And this is again methyl and primary oxidizing, but this is tertiary. This one is not oxidizing. So this is just existing as it is. Only primary, secondary, tertiary do not. 27, answer 2. 28, they were checking your direct theory memory. Sodium and below elements are making. Sodium and below elements are making peroxide, potassium and below superoxides, and so that lithium oxide, sodium peroxide, potassium superoxide, magnesium only the oxide. Question number 28, answer 2. Question number 29. Whenever we are doing electrochemistry question, you are like, your electrochemistry knowledge is less. That's because we did this, we didn't do this questions at the class. I posted you guys this recording. But if you say, convince to yourself, if you feel like unit 13 is weaker, then you're supposed to feel like all the other unit 1 to unit 12 is supposed to be really, really improved. Understood? But if you go through that, like very short recordings are there, I just want you guys not to give up unit 13 because that's a very, very easy unit. Unit 13 is very easy unit. I asked you guys whether you guys need a physical class, so I can stop doing this one of the paper. I can do unit 13, but you guys didn't request. I thought you guys went through these recordings nicely. What is the electromotive force of the... Okay, so this side is anode, this side is cathode. That is one way. Or otherwise, this is the negative value. This is the negative value. And this is the positive value. Blue is the positive value. So this is your magic box. As long as you know this one, then you know M is the anode oxidation anox, cathode red cat. Here also I have this cell reaction as well. Anyway, you only need this little thingy, cathode minus anode. So the value you can get very easily. Question number 29, answer 1. Whenever there are questions coming from electro, those marks are really solid, nice marks. Question number 30. They were given this reaction by adding equal amount of moles of W and X. They were adding equal amount. Okay, so N and N, let's say X is dissociating of this X. So if this is X, this is become 3 times 3X. How much making 2X and how much making here X? I'm just going to go like that because I don't want this going with fractions. So that N minus 3X, N minus 3X, N minus X, 2X and X divide by the volume, or you can cancel the volume. And then N minus X is larger than N minus 3X. Simply mean X concentration is supposed to be greater than W concentration. This is X and this is W. So that question number 30, answer 4. Okay, how many questions are correct depending on how much you guys are thinking about these questions logically. I know first 30 questions are always like you are reaching highest marks. You guys are that's what I'm saying. You guys are like chemistry, most part of chemistry is coming through this calculations, and then you guys are focusing more on calculations, especially the students who's doing maths. But remember, this is not chemistry. I was just keep asking you guys. අර maths වලින් ඔයගලන්ට හැමදේම prove කරලා පෙන්නන්න පුළුවන්. ලොකු equations දාලා they can prove that. But remember, at the end of the day, not the math part making you guys losing marks. Always, regarding you have better knowledge or not, you are losing marks not from the first 30 questions. There are no maths in 31 to 50. So the improvement of logical part is really important. Let's see how you would feel. Like go through one by one, thinking like what kind of things went wrong, why you couldn't get under like the 20 out of 20 from 31 to 50. Question number 31. Which of the following statements are always true? Spontaneous reaction that occurs at temperature T. Gives free energy delta G equals delta H minus T delta S. Reaction must have a positive entropy. Even the entropy is negative at low temperature, this can be, delta H can be higher, so this can be spontaneous. Reaction must have negative enthalpy. That's not again true. At high temperature, even when delta S is positive and this is negative, this can be, even this is negative. If this is positive, when the temperature is greater, this can be negative. So that's not true. Enthalpy change of the reaction must be negative. If the entropy change is negative, yeah. If this is negative, negative multiply negative become positive. So that to increase this side, this side, this is supposed to be highly negative. Only with that, this is become negative. That's true. Enthalpy change of the reaction must be negative if the entropy change is positive. Entropy positive mean when entropy is positive, negative multiply positive is negative. So, sorry, negative. So that if the temperature is greater, this side is higher, so that this is become negative regardless enthalpy. Question number 31. Only C correct, answer 5. Question number 32. True regarding the molecule. Okay, this one you can draw three-dimensionally like this. Then you guys can see this is planar, sp2 planar, or this is in one single plane. But let's see. All the carbons are sp2 true. All the carbon bond lengths are not equal. See, these two are pure single bonds, but these are actually all these are single bonds, but here this hybridization, actually hybridization is also same, all carbon-carbon bonds. But here this carbon-carbon bond is in between single and double bonds, not hydrogen carbon, okay? But this bond is a true double bond. So AB is the greatest, this one single bond, and then the benzene ring BC is the smallest. That's incorrect. Carbon atom labeled as ABC lie on a same straight line. ABC, C120, that's wrong. Carbon atom A and hydrogen atom attached to carbon B. Carbon atom A and this hydrogen. Same plane is all on same plane. You don't have to worry about that. That's true. D is correct. 32, AD correct, answer 4. Question number 33. Which of the following statements are wrong regarding the manufacturing of ammonia using nitrogen and hydrogen? Okay, like I know you guys are still saying, your memory for unit 14 is not enough, but let's say you have another 3 more months for the exam. So 3 more months mean 90 days. 90 days mean a huge time. Just little by little, go through the memory, improve your memory. Okay, nitrogen gas with 3 hydrogen gas, the temperature is optimum temperature, optimum temperature 450, not maximum. Pressure is 250, that's high. Iron is the catalyst, K2O is the catalytic promoter. And the temperature is, enthalpy is minus 92, that's exothermic. Nitrogen is obtained by the fractional distillation of liquid air, true. Ammonia formed is continuously removed by liquefying it, yeah. The reaction between nitrogen and hydrogen is exothermic. Remember, they want you to memorize this one. Pressure is 250, but the temperature is 450, not 850. Very high temperature makes the reaction go backward because this is negative value. So that's why it's wrong. Question number 33, C, D correct. Answer 3. Question number 34. Consider the following reaction. They were saying closed system. They were saying this enthalpy is exothermic. Which statement given below is correct? Correct statements are asking. Increase the pressure. All are gases, 3 molecules here and 1 molecule here. Increasing pressure reaction goes to backward. Sorry, forward. Yeah, so the product is increasing. That's true. That's true. Increase the temperature. Reaction supposed to go backward. Decreasing the product. So the reaction is going backward, means product is decreasing. Third one is wrong. Catalyst doesn't increase the product amount or yield. Activation energy increasement, that's okay, again, increases the activation energy of reverse reaction. Use the catalyst. Both decreasing, not increasing. That's wrong. Both decreasing. Question number 34, A, B correct. Answer 1. Question number 35. True regarding compound Q. Q can exist in 2 isomeric forms. Q has this double bond. So cis trans is there, not LD. Cis trans is there too. This one, when you're reacting with the Br2, so this is producing these 2 carbons. Both carbons are having chiral, has 2 chiral. Not wrong here, not wrong here. Obtaining Q reacting with H2 exhibits optical. Now if you add hydrogen, then this is become CH2 and CH2 here. So exhibit optical is wrong. Exhibit optical is wrong. And then sodium borohydride exhibits sodium borohydride. If you add sodium borohydride, COCH3 becomes CHOHCH3, but this COOH is not changing here. So that is still this, the cis trans is here, but they are not asking anything about the cis trans, they are asking about this chiral carbon here. This carbon is chiral, so that's again true. It is showing the optical isomerism here. Question number 35, A, D correct. Answer 4. True with the regarding of electromagnetic radiation of wavelength 200 nanometer. Nu is inversely proportional to lambda. Higher frequency than radiation of wavelength of 400. Inversely proportional, yeah. 400 nanometer, then nu is supposed to be greater. This is inversely proportional. It is in the visible region of the electromagnetic. Visible region, remember, 400 to 700, that's wrong. EMR vacuum 3 into 10 to the power 8, it's wrong. Photon has a higher energy than the photon radiation of wavelength 100. Inversely proportional. 100 supposed to be having the higher energy, lower wavelength higher energy, that's again wrong. Question number 36. Answer only A correct, 5. Answer 5. So they were given a couple of these. If I add everything to this magic box, so the highest negative to highest positive, highest negative to highest positive, highest negative to highest positive. So the first one, small amount of Fe2 plus to Fe2 plus to Fe3 plus. Prevent this oxidation. Ion metal Fe2 plus Fe3 plus value is 0.44 minus 0.44. Adding a small amount of iron metal to the solution. Iron is plus 77. This oxidation potential potential is minus 0.44. Which of the following method can be used to prevent the oxidation of Fe2 plus to Fe3 plus? Yeah, this is more negative. Minus 44 than iron, Fe2 plus Fe3 plus. Fe2 plus Fe is minus 44. Fe2 plus Fe3 plus plus 77. Yeah, so this is happening. This is happening. When you add iron, it is oxidizing rather through this reaction, so that's possible. A small amount of zinc 2 plus. Zinc cannot oxidize zinc 2 plus further. Cannot oxidize zinc 2 plus further because zinc 2 plus is already oxidized. A small amount of silver. Silver is way below. You cannot oxidize silver. Addition of small amount of zinc. Yeah, zinc is possible. Zinc very easily, see, very easily it can oxidize to zinc 2 plus. So the fourth one is also correct. And this is also correct because this is above this value. This value is above this value. 44 වලට වැඩි මේක 15 නේ. එතකොට -44 එක කෙනාව easily reduce කරන්න, oxidize කරන්න පුළුවන්. You getting this one? Okay. Question number 37. A D correct answer 4. 38. So how is electron? Yeah. Because your answers are correct. Yeah. Which of the following true about the equilibrium given below? Yeah, even this is solid, it has to be present, that's true. It has to be there for the reaction. The expression of the equilibrium constant does not contain the term, this one, and H2O liquid, because they can be considered as constant. Yeah, that's what the part we call derived equilibrium constant. If this is aqueous, see the aqueous and aqueous, so this is the medium. Increasing K plus aqueous concentration in the system drives the point of equilibrium to the right. If you increase this one, reaction is going to backward, left, that's wrong. Addition of KNO3 is solid. Solid does not change equilibrium, that's wrong. Question number 38, AB correct, answer 1. AB correct, answer 1. True regarding this compound, when T is heated with aqueous sodium hydroxide, ammonia is liberated. Yeah, this NH2 becomes NH3, that's true. Ammonia is produced in the reaction T with sodamide. That's again true. Sodamide, this NH2 is reacting with this hydrogen to produce ammonia. Metallic silver is deposited, that's wrong because this has terminal alkyne, so it is giving this white precipitate, not the silver mirror. When T is reacting with acidic Hg2 plus, that is the alkyne hydration, by the alkyne hydration you're going to get the double bond here. So this is the product, this is the product. Markovnikov rule, so you are getting ketone, here, not aldehyde. So that is incorrect. 39, A, B correct, answer 1. 40, see how many questions are incorrect and make sure you are not doing such mistakes again. Improve your thinking style. Which of the following statements are true regarding polymers? PV is thermoplastic polymer. Nylon 6 is made up of the polymerization of 1,6-diaminohexane and hexane dioic. Yeah, COH groups and NH2 groups to make these amide bonds true. These are not thermoplastic, thermoset, urea formaldehyde and phenol formaldehyde, bakelite. Polystyrene is made up of addition polymerization of styrene. Yeah, that's true. Styrene. This is the benzene ring. CH2 with benzene ring. B, D correct. Question number 40, answer 5. How many questions are incorrect from question number 31 to 40? Make sure you are improving your thinking style because I know you guys have the knowledge. if somebody is directly asking you guys to explain the theory, then you would do it really nicely. But when they are twisting the question, twisting the theory with answers, then you cannot do that. Why is that? Because you have to improve your thinking style. There are a couple of these students, there were a couple of students in my history. They did these questions right ahead of exam, right before the exam. Like you have 1.5 days. During that, they did like 31 to 40 or 41 to 50, whatever the part they're missing. Okay, moving to the next set of questions. Question number 41. Solid sulfur react with hot conc H2SO4 to give SO2, not SO3. Hot conc H2SO4 act as dehydrating. That's true. 41 answer 4. Out of these two, this is more basic. That's true because we have readily available lone pair here, but this one here delocalizing with this CO. The lone pair of the electron on the nitrogen atom of amide is delocalized into the carbonyl group. Yeah, that exactly is the reason. 42 answer 1. When zinc 2 plus is added to a solution of copper 2 plus. Metallic copper, see, this is, they want you to memorize, this is a galvanic cell easily. Zinc is always oxidizing. Zinc is always oxidizing. But here zinc is already oxidized. The reaction is supposed to go with zinc, not zinc 2 plus. Zinc 2 plus already oxidized, it can't do anything. See, they are trapping you. So the first statement is, that's why first statement is wrong. The standard reduction potential of copper is more positive. That's true. That's true. Galvanic cell. Question number 43, answer 4. 44. Reaction of ammonia with sodium gives H2 as a product, whereas reaction of ammonia with Cl2 gives N2 as a product. Here, plus 1 reducing to 0. Here, minus 3 oxidizing to 0. So, oxidizing and reduction both happens here. Ammonia acts as an oxidizing as well and reducing agent. So, both conditions are possible here. So, here the answer is 1. Sodium with ammonia gives H2. So, plus 1 to 0 reduction. And here, minus 3 nitrogen goes to 0, that's oxidation. So both these are occurring, so that both are possible because this is going through oxidation and reduction. So that question number 44, answer 1. 45. The boiling point of 2,2-dimethylbutane, that is this one, supposed to be less, not higher. That's wrong. Because this is straight chain, surface area high, so the melting boiling point high because of the London forces. In molecules, as the surface area decreases, yeah, when the surface area decreasing, strength of London dispersions are also decreases. That's why this is supposed to be not high, this is supposed to be less. So that the 45 answer 4. Incorrect and correct answer 4. All the molecules in an ideal gas move the same speed. No, that's why we're going to talk about the mean square speed. Why? Because their speeds are different. That's why we have the Maxwell-Boltzmann distribution curve. See, speeds of each of these movements are different. There are no intermolecular interactions. That's true. So the 46 answer 4. H2O2 is used in the manufacturing of nitric acid. No, manufacturing of nitric acid we are using oxygen. That's again atmospheric O2. Osborne method, unit 14. H2O2 always act as an oxidizing agent. No, H2O2 can act both as oxidizing and reducing. That's wrong. Both statements wrong. 47 answer 5. Benzene diazonium chloride react with phenol to give an orange color dye. To give the orange color dye, the temperature is supposed to be lower. They were not mentioning the temperature mean. Temperature is supposed to be high. So that this is not existing. So it's not giving this dye. It's not giving color, anyway, okay? Diacetyl salt act as a nucleophile. That's again wrong. This is definitely wrong. Since they were not mentioning the temperature here, you cannot say exactly it is giving this color compound, so then it is fine. But if the temperature is correct, this is possible. Then the answer is correct. So that the answer is 3. So they were taken both answers 3 and 5. Okay. Question number 48, 3 or 5. Question number 49. The rate of elementary reaction increases with increasing concentration of reactants. When you double the concentration, other than zeroth order, first order double, second order 4-folds, third order 8-folds, that's true then. The rate of an elementary reaction is always linearly proportional to the concentration of the reactants. Linearly proportional only with their proper let's say if it is zero order, there's no, if it is first order, this is supposed to be a to the power 1. This is a to the power 2 and a to the power 3. So, to the concentration, this is not linear. If you go with a to the power 1, this is going like this. Clear that? If this is a to the power 3, 1, if you make it a to the power 1, this is not linear. So, they were not saying the power of concentration. They were just saying the concentration. That's why this second statement is wrong. Power of the concentration, then it is correct. So that's why this statement is incorrect. Question number 49, answer 3. 50 usually comes with unit 14. Formation of ozone at the lower level in the atmosphere requires the presence of hydrocarbon. For upper atmosphere, ozone is favorable but unfavorable in lower atmosphere. With hydrocarbon, it doesn't happen. By lightning effect or by burning fossil fuels, ozone is producing in lower atmosphere. First statement is wrong. Hydrocarbons react with oxygen in the presence of light to produce ozone. There is no such thing. Ozone with the lightning. So, these free radicals of NO through this and producing this oxygen that can make ozone. Not with these hydrocarbons. Both statements incorrect. Question number 50, answer 5. Okay, I'm showing you guys this one if anybody misses to get answers here. In the meantime, I want to know your marks. Plus, I want you guys to write your own reviewing just to understand what went wrong. Write your own reviewing. When you are moving to the next paper, how would you reach 50 out of 50? Which part you supposed to improve when we are going before the next paper, and I want you guys to each week read those reviewings that you done from the 2000 to 2014 and make sure that you guys are improved that part. When you go through that again, you wouldn't feel it cannot possible. You cannot say I have forgotten this and that. Okay, so now it's time to write your own reviewing. Okay, district first Deepna has gotten 45, Bayan has gotten 47. So make sure, it's up to you. Like you guys can improve every day. Don't worry that they got highest marks and you are less than that. Let's say we want to district first, even district 100 is alright. Just keep it up. Okay, so we are moving to the structured essay. The very first one, they are asking the decreasing order of ionization energy. You are going with the third period. And then to that, you are inserting the second period one. And then the second one, I'm going with the Sinhala one because Sinhala one has better explanation. First, electron gain energy. You guys know chlorine, sulfur, oxygen. This is the one we did at the theory class. But this time they were adding carbon. Carbon is supposed to have the least electron gain energy. Melting points are going with because here all those halogens are same, so we are going with this cation, barium, calcium, beryllium, polarization power. And for bond angles, you guys just have to go with this structures drawing, and then you have to go, this is tetrahedral 109, pyramidal 107, and square planar 90. So SiCl4, NCl3, ICl4 minus. Okay. Electronegativity of oxygen. First you are going with the hybridization, it is same. First with the hybridization, that's same. And then the second criterion is the charge. So you can go with the charge, plus charge, neutral, minus charge. If charge is same, oxidation number, if oxidation number is same, nature of surrounding atoms, even for these modern papers they are using, even for 2025 paper they are using this little method. Last one, NO bond length, that's for that you have to draw the structure and see their resonance. And this is NO single, this is double bond but two resonance structures. But this one, the real double bond, no resonance structures. Last one is real triple bond. So this is the order. Okay. 5 marks for each. Make sure that you write this incorrect part, that you can add marks and get answers easily. And then this resonance structures. 4 resonance structures are asking. Lewis and then resonance. Sometimes they give marks, sometimes they don't give marks, so that they are not giving marks for electron transitions. They are not giving marks for these electron transitions. But sometimes they give marks to this double-headed arrow, so that I make sure always show that. Okay. And then this is again, I'm not explaining, you guys have this better understanding. Just check. Electron pair geometry, C2 linear, shape linear, hybridization SP, N3, trigonal planar bent SP2, C4, trigonal planar SP2, N5, N6, tetrahedral pyramidal SP2. And here, online kids, if you have any issues, just WhatsApp me. You can talk to me later. Or otherwise, you can go through the recording again. Request the recording if you want this again. Okay. To show angles. So they were given 3 marks for sketch. And these angles, 1, 2, 3, 4, 5. 5 marks. See, sketch the shape of the Lewis structure. Lewis structure shape. Understood? And if you go through this question from, let's say, from 2000 to 2012 we did so far, you were always drawing this kind of a structure. You never draw orbital diagrams here. Come on. There is no such single word there, orbital. Okay, identifying these orbitals. N1, SP hybrid orbital, O2p atomic orbital sigma or pi, and C2 sp hybrid orbital. Here C2 sp hybrid orbital, N3 sp2 hybrid orbital, N3 sp2 hybrid orbital, C4 sp2 hybrid orbital. Here you can go with either single bond, sigma, or the double bond pi bonding. They were given marks for both. And then they were given this data here for you guys. Boiling point is 249, boiling point is 316, mean this boiling point is greater. But the intermolecular interaction is which substance has a larger dipole moment. Larger dipole moment is going on to this one because the electronegativity difference is greater and the shape is same. Stronger London dispersion is supposed to go on to boiling point is greater, so that is CH3I. So that which substance has a stronger total intermolecular attractive forces, that is CH3I, because they were given the data, boiling point is greater. So that we can get the conclusion here, which intermolecular interaction is dominant, the London dispersion. Since the London dispersion is greater, this has higher boiling point, even its electronegative difference is less. Okay, moving to question number 2. X is an element in the third periodic of the periodic table. So they were given this, they say it is third periodic. And then the gap between these two are greater. Gap between these two are greater. So once you remove the third electron, removal of fourth electron is difficult. So that this is supposed to belong to third group. Third group is aluminium. Understood? Identify element X. Hanging, let's see. Write the ground state electronic configuration of X, that you guys can do that. Given the most stable positive oxidation state of, that's only +3 it has. Balance chemical equation for the reaction of element X with, check the marking scheme. I guess they do give. X කියලා දිනන නැද්ද? Give balance chemical equation for the reaction of element X with. Usually they do give, because element X, they just say element X. They didn't say anything. Usually they give marks for normally X and for element. How come you were not going with the element? Because writing X is really difficult. Element aluminium here? Seriously? No, they always give with the element. දැන් ඔයාලට පිච් එකක් අරගෙන ඔළුවට දාගන්න ඇත්ත නේද? That's the reality. Some do play like crazy stuff. And then X burns readily in air or O2. So this is aluminum oxide is, and heated with sodium nitrate. So this is this ionification test they are asking. See how many times they are just throughout the whole this practice level, how many times we did write this equation. So it's important. Then write the formula for the chemical species that the ion of X having the most stable oxidation state. Okay, if it is in aqueous medium, you can go this one, or even this one, or even this one is okay. Remember, predict that what would you expect to observe when a small amount of sodium carbonate. Remember that for chromium hexaaqua or aluminum hexaaqua, when you add more and more water, this H2O is getting away as H plus and OH minus. That OH minus is rejoining with the coordinate complex, but H plus is releasing to the medium, so medium is acidic. To that medium, if we add sodium carbonate, the observation is evolution of gas bubbles. Evolution of gas bubbles. They were given 5 marks for that. Use of X or use of aluminium, alloy, aircraft bodies, cooking utensils, drinking cans, electric power cables, aluminium paints. See the part B. This again is very easy. They were having all these not in order. Barium chloride and ammonium hydroxide solutions are also provided. Okay, when you add barium chloride, clear solution means there are no precipitation. No precipitation comes with magnesium nitrate and potassium chloride. So I've sorted out that part. Then when you add ammonium hydroxide to these two, you guys know magnesium nitrate makes magnesium hydroxide precipitate. So that then the next one's supposed to be potassium chloride. So if we figured out these two now, I'm moving on. Next one, white precipitate insoluble. And on tarike patan ganna pulan if you even if you can start here. Soluble in hot water, these precipitates supposed to be coming from lead. So you can separate lead. And then dissolve and undissolve. These two. Dissolved one is carbonate, undissolved one is sulfate. That's very easily you can get A lead nitrate, B zinc sulfate, C sodium carbonate, D potassium chloride, and E magnesium nitrate. And then they are asking these equations. Check your answers. Equations for forming precipitate, and they want you to write this, show this arrow as well. The one which is precipitating, they want you to show which one is precipitating. Dissolution of the precipitate, see the very first one, solid to aqueous, that's all. But the zinc is making this coordinate complex, and this one is getting dissolved because it's releasing carbon dioxide and converting to barium chloride. So these are the reactions. So see, if you have not shown this downwards arrow, they want you to cut 1 mark from each answer. Did you guys write those? Yes or no? They were given these. Okay, so now you guys have to understand when you're going through this part, you guys are doing a lot of mistakes to lose marks. It's not your knowledge. That's why you need better practice with papers. You have the knowledge, but still you guys are doing mistakes. And your mistakes are your own mistakes. Because no two students do the same mistakes continuously. Two students do two different mistakes. So to understand your own mistakes, you guys have to live with this. You guys have to live with these papers. I'm worried, but I can involve with that. එක නිකන් අර මම බලෙන් මගේ ක්ලාස් එකට එන්න කියනවා වගේ එකක් මේක ethical නෑනේ. Otherwise දැන් අර අම්මි කෙනෙකුගේ පුතෙක් වුණා නම් එනවා කරනවා පන්තියට කියලා කියන්න පුළුවන්. නේද? කරනවා මේක හරියට කියලා කියන්න පුළුවන්, but I can't say that. Okay, question number 3. 1 moles per cubic decimeter solution of Y. So 1 moles per cubic decimeter Y. A weak acid HA, and its pH is 3. So the given data are there. So they were taken 100 cubic centimeter of that. They were taken 100 cubic centimeter of that. Was placed in a shrinking bottle with 100 cubic centimeter of any organic layer. After shrinking, they were keeping it water bath in 30 minutes for the distribution. 2 layers were separated. And the aqueous layer they were named as Z. And from Z they were taken out 25 cubic centimeter. Titrate with 0.01 M40. 0.01 M40. Because we have CV. See the curriculum which we were always talking about, now we are really there. Calculate the degree of dissociation alpha. To calculate that, we don't want any of those, but we know they were given this pH equals to 3 here. Even this one you don't want, even I have written that, but they were given this dissociation. Let's say the initial number of moles is 1. Actually that's 1 because 1 moles per cubic decimeter. Let's say alpha is dissociating 1 minus alpha and alpha. But we need this alpha. H3O plus equals to alpha. But they were given this as a data, pH equals to 3. Go with the minus log 10 H3O plus. That is 10 to the power minus 3. So that the H plus concentration or this alpha equals to 1 into 10 to the power minus 3. Remember that there are no units. 1 into 10 to the power minus 3, you got 4 marks. For not writing units, they are adding another 1 single mark. See, this is not the knowledge. This is the way you are expressing your answer. You have the knowledge. Calculate the dissociation constant of HA. That's again C into 1 minus alpha, C alpha and C alpha. Then write the Ka expression, and then this is C into 1 minus alpha become C, because alpha is negligible. So this is C alpha squared divided by this C here, this C here. So Ka equals C alpha squared. Remember, this is also dilution law, but we have to show all the steps here. So this Ka equals then C is 1 moles per cubic decimeter. Alpha we already found 1 into 10 to the minus 2, but you have square here, square value. So it's 1 into 10 to the minus 6. We need Ka for the next part. That's why they want us to calculate that. Then again, in Z solution, they are again asking alpha of the dissociated amount, but this time this reaction is there. HA reacting with sodium hydroxide, distribution is there. Let's see how much is remaining. HA reacting with sodium hydroxide, 1:1 ratio, CV of sodium hydroxide given. So that is the same amount of number of moles of HA in aqueous layer, but they were taken 25 centimeter out. So then 0.8. මේ බලන්නකො 0.8 නේද remaining 0.8. ඉස්සලා කොච්චරක් තිබුණාද? Remember you had 1m, now 0.8. But earlier we found out Ka equals C alpha squared, then alpha equals Ka divided C root value. So Ka we already calculated, and then the C here we calculated 0.8. Simplify this, then the second one's alpha or the dissociated amount is 1.118 or 1.12. ඒගොල්ලෝ මේ ඔක්කොට marks දීලා තියෙනවා. Even it is 1 into 10 to the minus 3, they were given marks. Oops, මම ඉන්නේ සිංහල එකේනේ. And then using alpha and alpha prime, comment the relationship between the degree of dissociation and the concentration. See, alpha is 10 to the minus 3 when C is 1. Then alpha is 10 to the minus 3, 1.1 into 10 to the minus 3 when C is 0.8. See, when the concentration is less, alpha has increased. That is also dilution law. When concentration is less, dissociation is increasing. So that during the dilution, dissociation is increasing. Then they want us to find Kd. Initially you had 0.8. Sorry, initially you had 1. Now you have only 0.8. 1 minus 0.8 remaining in the aqueous becomes 0.2. So that the Kd equals to 4. Are these questions difficult? Extremely easier. So make sure you are reaching full marks, 100 out of 100. That is the target. pH of a mixture containing 25 of Y and 25 of 0.5 m sodium hydroxide. Okay. HA initially concentration is 1, but they were given 25 out of that, so that the number of moles is this. And they give the CV of sodium hydroxide, and then number of moles is this. So these are the number of moles. See, this is 25, this is 12.5, this is fully using, and the same amount of 1:1 ratio, same amount of NaA is making. And then the difference between these two is the remaining HA of the medium. So the remaining HA of the medium, so that become this. So that if you have in the medium this remaining HA and this amount, and this formed NaA and this amount. See, these two are exactly same. So you don't have to do these calculations separately. You can write HA aqueous equals NaA aqueous equals, so on you can write once. Anyway, once you calculate, you're going to get the same concentrations dividing by same 50, and then get the Henderson equation. But this is like, cancelling off. You know that, cancelling off. So this is cancelling off. So that pH equals pKa. So that Ka equals, pK equals 6. You can logically say this one. Since these two are equal, this is cancelling off. This is cancelling off, so that pH equals pKa. Okay. Okay, moving to question number 4. Are you guys okay here? Question number 4. A and B are structural isomers. Chain, position or functional group, any are possible. Of methylpentene, okay, so it's methylpentene, I have no idea, just 5 carbon, 1 CH3. CH3 can be joined only to here, here or here. I have no idea, I'm just drawing one single structure, okay. With the molecular formula of C6H12 mean, they are supposed to be a double bond. A exhibits geometric isomers, B exhibits optical. So the easiest way is to start it from B. So what I'm going to do is, I'm going to just write the middle carbon and then 1 hydrogen, 1 carbon, 2 carbon and 2 carbon. So that this is the skeletal structure. This is the same skeletal structure. So, optical isomerism. And then if you put this double bond here, if you put this double bond here, that's again showing the optical isomerism. So, to lose the optical isomerism and to get the cis trans, only possibility is moving this double bond even here or here. Then you are getting the same structure. Exactly same. See, I have moved it here. It was here. It was here. I'm moving it to here. It was here already. So that this is your B, optical. This is your A, cis trans. Clear? The same skeleton. I guess that's all you need here. Oh, I want you guys to go with the hydrogen as well. Make it in the hydrogen. Yeah, this one has hydrogen. It's a must to go with hydrogen. So that this is A, cis trans, this is B, and when you add hydrogen, no double bond, but still you are maintaining the same skeleton. See the same skeleton. The middle carbon is having this CH3 group. ඊයේ මම පොඩි වැඩක් කරා ඊයේ ක්ලාස් එකේ 27 සෙට් එකට 28 කටියක් කරන්න ඕනේ. කියන්න මල්ලිට. I was given this instant exam. They were like so upset. From unit 1 to 5. They didn't know. Yeah. We are in organic, but I want to make sure that they are memorizing first 5 minutes. Baby, it is true, but you need that to reach 100 marks. Okay. Then that part. See, even I have shown this one to make sure that you guys are memorizing this. For 2027, we have done this isomerism. Okay. So this is A, and then HBr, hydrogen goes to where hydrogen is high, and then adding KOH, OH, and PCC, CO, and then to B, anti-Markovnikov. So B has double bond here, so hydrogen goes to where hydrogen is low, so bromine gets to the terminal, OH, and this is CH2. This is the part they are just, the concerning. And then, using F and I, oh, this is correct. See, that's why I'm going this way, like then let's say some weaker students are still writing answers, you guys are just waiting. I don't like that. I usually have this conclusion. If you go through my path from the beginning to end, reaching 100 marks is really easy. Let's say there are very, very weaker students. Like ඊයේ ලොකු කතා නැත්නම් කිව්ව පුතේ අනිත් ක්ලාසස් වල හිටිය ළමයි 6 දෙනෙක් ඇවිල්ලා ඉන්නවා දැන්. මේ සැරේ ටර්ම් ටෙස්ට් මාක්ස් ගොඩක් හොඳයිනේ මගේ ස්ටුඩන්ට්ස් වගේ. හොඳටම හොඳයි. ෆර්ගසන් එකේ 95.5 ඉඳලා අරකේ 70 ගණන් තියෙනවා වැඩිම 86ට කොහෙද ඉතින් 70 ටොප් ගණන් තියෙනවා. So ඉතින් අලුතෙන් ළමයි එනවා. So remember I did this exam yesterday. So එතන ළමයි මම හිතන්නේ පස් දෙනෙක්ගේම ලකුණු මාර අඩුයි ක්ලාස් එක අලුතෙන් ආපු අයගේ. ඒ කියන්නේ ඒගොල්ලන්ගේ ලකුණු තිබුණේ 15 ඉඳලා 10 හරිය වෙනකම්. out of 50. ඒතර මගේ එක ස්ටුඩන්ට් කෙනෙක්ට එයාට ලකුණු 15යි. එයා ඉතින් පිස්සුනක් කියලා එයාම කියනවා. and then ඒකේ වැඩිම තිබුණා හිතන්නේ 44. yeah 44 ඉඳලා එහාට ලකුණු. එතකොට අර පාට එනද වෙනස? yeah so then mama හිතනවා මේ level එකට once you guys are in this level still you guys are very weaker. I'm not the person to support you guys. Then you have to go to like very slow class doing very simple stuff. This class is for students who need to reach this high flying. Okay, F is ketone, I is aldehyde, E the tolerance. You guys have to write both answers. Ammonium silver nitrate, not here, this is silver mirror. Or failings, not here, aliphatic aldehydes, brick bread. Acidified K-MnO for dichromatic CrO3, you can use any of this. And Z and H. What is the isomerism they are asking? See the same exact structure, same exact chain, and same exact this. Only difference is the position of OH. So it is position isomerism, OH function group, position isomerism. That's easy. Okay, this. Electrophilic addition, double bond is breaking, and the product. This one CH2, reaction type is, so this is meta-director, so the Friedel-Crafts acylation, so it's supposed to join into the meta position, electrophilic substitution. OH replacing with Cl, nucleophilic substitution. This is dehydration, so elimination of water molecule, elimination. Here, to this one, you are joining this R group here and this one is ketone, so those two are staying here. Here I am showing this mechanism. CO bond, through the CO bond nucleophilic addition. And then they are asking the mechanism of number 2. Number 2, මොකක්ද ඔයගොල්ලන්ට තියෙන එකම අවුල මේකේ make sure that it is joined into the meta position of this one. මේක තීගෙන අරින්න. එයා තිබුණාවේ. එයාට meta position එකට මේක join කරන්න ඔයගොල්ලන් මේ පුළුවන් වෙන්න ඕනේ. meta position එකට. Then just maintain this one the same. And see මේකේ the next part එකේ අහලා නැහැනේ. They were not asking from the next part. Explain this resonance stability. Then they want you to draw this one inside here. So you can usually go the normal way and then you can draw these all the resonance separately. See. මේකේ අහලා තියනවද? Explain why. Yeah, explain why කියලා අහලා තියෙනවා. තිබ්බත් නැත්නම් මේක definitely අදින්න. Positive charge on intermediate delocalizers in benzene ring. By this resonance stability, intermediate is stable. Whether they ask that or not, you guys got to write these three resonance as well. And see how they were given marks here. They were given marks for this equation. And this arrow here, 3 marks. And for this structure, exactly from the negative charge, you're going to show it. See, 2 marks here, 1 mark, 1 mark, 1 mark. Okay, so from 2012 so on, like they are giving marks for byproducts as well. Must to show everything. Writing for the delocalization, they are again given 2 marks here. Okay, you want to go to the break and come back, or are we going to do this? Okay, moving to essay. Okay, this is the last part anyway, if you want to copy anything from this. Okay, moving to question number 5. So, marks from those 4 questions, you didn't lose much. Wow. Yeah. එකකට එතකොට ඉතනක 90 කියලා 312ද? නෑ ඊටත් වැඩි. I'm just going to read this one. Whatever these versions, they were accepted. Raoult's law. In an ideal binary solution at equilibrium, vapor pressure of a certain component is equal to the product of its saturated vapor pressure and its molar fraction in liquid phase. Or otherwise, you can go with this equation, PA equals to P naught A XA. Then you're going to introduce this PA, partial pressure of component A, P naught A, saturated vapor pressure of A, and then XA, molar fraction of A in liquid phase. Or otherwise, they were accepting this one as well. This is the second version of Raoult's law. In an ideal binary solution at equilibrium, the relative vapor pressure depression of one component is equal to the molar fraction of the other component in the solution in liquid, and otherwise this one. XA equals PB minus P naught B minus P naught B. Then you have to introduce again what is this XA, PB and P naught B. Okay, anyway, so this question is extremely easy question. A and B form an ideal solution. This solution is in equilibrium with its vapor phase in a rigid container. The amount of A and B in moles in the liquid phase is NA and NB. So the liquid phase A and B are NA and NB. Okay. Standard vapor pressure of A and B are P naught A and P naught B. Calculate the partial pressure of A given that NA they were given 0.1, NB 0.2, and the partial pressures P naught A, P naught B given. But this paper was really challenging, but students didn't reach like very high marks. I don't know what you guys said. Okay, so the very first part, calculate the partial pressure of A. PA equals P naught A XA. P naught A equals 1 into 10 to the power plus 4. Since this is 0.1 and 0.2, at the same place I have calculated the molar fractions 1 over 3 and 1 over 4. See, they were given marks. You had to mention somewhere. So that the PA equals 3.33 into 10 to the power 3 Pascal. Same way you can calculate the PB as well. To calculate the total pressure. To calculate the total pressure, we are going with the Dalton's law of partial pressure. For that, we need PB. So let's calculate the PB the same way. PB equals 2.22 into 10 to the power 4. PB equals P naught B XB. So that the total pressure is this one. Then substitute PA and PB. So the total pressure equals 2.63 into 10 to the power 4 Pascal. මෙතන අන්තිම එක නේද 2.66 ඔයා 6 එක ගත්තද හරි it's definitely correct. මෙතන 2.66 මම දාලා දින 63 කියලා. Okay. Gas C, question number 5 part B. Gas C dissociates into gases D and E. Again they were given just one single mole here. 1 mole of C is initially using at the end of the day 0.2 of C. 0.2 of C is remaining here, so that the dissociated amount is 0.2. So 1 minus 0.2, C reacted amount is 0.2, so the remaining is 0.8. And here 0.2 into 2, that is 0.4. And then the last one 0.2, exactly same. Then you can get the total number of moles here by adding, that is 1.4. And then get the molar fractions dividing each of these by the total number of moles, and then total pressure is given as 10 to the power 5. The first part, they want us to calculate the Kp, write the Kp expression, do the substitution, and get the answer. This number is easy, or otherwise now method substitute කරන්න ඕනේ මේකලා marks දීලානේ substitution you have to do the substitution and then do the substitution again for the Kp and get the answer. Kp equals 2 into 10 to the power 8 Pascal squared. I do it only minute. And I'm going to eat only melon, sweet melon, I'm going to eat only melon. Okay, then calculate the equilibrium constant Kc, temperature is 500. Kp equals Kcrt delta n, 3 minus 1 equals to 2. And then Kc equals Kp divided Rt squared. And then Rt, instead of this R, I'm going to go with this square value. And then these two 500s are here, square values. You can very easily simplify this one. Kc equals either 11.75 mole squared meter to the power minus 6. I don't know, how are they going to get it? Okay, may have from Harini. Yeah, that will be the first 20, first 30 is wrong is there. You wrote your own mistakes, now you know what mistakes you did. So you can make that. Dedication only needed. Okay, part 3. When the temperature of the system was lowered to 300 Kelvin, that is T2, it was observed that part of D is liquefying. C and E remain as gases. Okay, C and E just existing as gases and insoluble in liquid D. Saturated vapor pressure of D. Now only the pressure comes from D because others are not liquefying. Okay, saturated vapor pressure come only with D. The amount of C dissociate at T2 is 1, then calculate Kp, 0.1. Okay. Then again, this is a reaction. They want us to calculate this Kp. We again need these three. To find that, I'm going to start again. Initial concentration is 1 here, same. Let's say this time, the amount of dissociation x equals to 0.1. So that 1 minus 0.1, 0.1 multiply 2, 0.1 multiply same, 0.1, 0.9, 0.2 and 0.1. And then total pressure not given this time. But we can find partial pressure of D. This is supposed to be equal to the saturated vapor pressure of D. It cannot be two different stuff. Liquid D we neglect. They were given the saturated vapor pressure here, so that the saturated vapor pressure of this D is supposed to be its own normal pressure. So that is the partial pressure of D. So that we know this one. Then we don't know these two. We don't know both PE and PC. PE and PC. But you guys know both these stoichiometric ratios are 1:1. So if we divide 1 by 1, even if we don't know their total pressures, we can get answers easily. So even if you can write like, let's say the total pressure I'm going to get as just PT, and total number of moles, let's say NT. NT is not changing, so that we can write these PE equals to molar fraction multiply its total pressure, but again with the molar fraction I'm going with the total number of moles as NT. Even because part is liquefying here, I don't know that part. So that I'm going to use a symbol here. Let's say the total pressure, so total number of moles is NT, and then the total pressure is PT. So I have two expressions for PE and PC. So that PE and PC, I'm going to substitute those two. But this one is exactly, I know that is this saturated vapor pressure is this one. So that simplify, when you simplify, PT, PT cancelling off, and then NT, NT cancelling off. So that only non-numeric values are there, you can get the answer then. So that Kp equals to 2.78 into 10 power 4 Pascal square. Oh. Found. Wow. Yeah, you can find those answers, but then it takes like a lot of time and a lot of work. Yeah. Then it's losing your timing. Okay. Moving to question number 6, which first part come from number 7 again. 7, 8. Oh. Mitani 6 එක pictures ගන්න නැතුව මම 7 එකේ twice pictures අරගෙන. 10. Yeah, it's not there. Give me a second. Okay, moving to question number 6. Gas A decomposes with this elementary reaction. Write the rate law. First they want us to write the rate law. So this is the rate law. Since I have written K, I'm usually introducing. Sometimes they give, sometimes they don't. I don't care that. Rate constant. Since elementary stoichiometric ratio equals to order, it's not necessary to write that one. The above reaction was started by introducing 1. See, A amount is 1. Moles to a rigid container, temperature is 300. Initial pressure is 30 kilopascal, increased to 32. Okay. So they were again talking about this pressure, and then we know pressure is proportional to number of moles in 10 seconds. When the experiment was repeated to 400 degrees Celsius, Kelvin, initial pressure went from 40 to 45. So first time it's 2 Pascal, second time it's 5 Pascal. So the answer is very obvious. Calculate the amount of air decomposed in 300 and 400, and then giving reasons show that K2 is greater than K1. Okay, so that I'm going with these two conditions. Okay, anyway, if let's say alpha is dissociating, so this is 1 minus alpha, alpha and alpha, and then the total number of moles then equals to 1 minus alpha plus alpha plus alpha, that is 1 plus alpha. Okay, so PV equals nRT, so that we can say pressure is proportional to number of moles. So the first condition, pressure is proportional to initial number of moles. Second condition, total number of moles is 1 plus alpha. And then the second pressure is equal to proportional to 1 plus alpha. If you divide 1 by 1, only unknown one is alpha. Only unknown one is alpha. So the alpha for the first condition, 300 Kelvin, that is 0.6. And then the same way, let's say this dissociation is beta. And that is 40 is proportional to 1 mole, 41 is proportional to 1 plus beta, exactly same way. Okay, that time, and then the beta equals to 0.125. Done. Done. And then rate equals delta A divided K delta T, which equals to K1 into A, so that rate at 300 Kelvin actually, yeah, Kelvin. 300 Kelvin, delta A equals to 1 mole per cubic decimeter 1 mole. And you have to divide that by the volume to get the concentration. and then time is 10. That's supposed to be equal to, here again, K1, I'm just writing that, and then they were given the initial concentration as 1, so that 1 divided by V. That is not changing. Initial concentration is not changing, but at 400 Kelvin, again, 1 is the initial number of moles, and then 8V is the the 1 over 8V, and 1 over the 15V are the number of moles. So that if you divide that by the time, you are getting the rate, and the other side again you have same 1 over V. See, either you can take these two values, either these decimal values, or you can get this one as 1 over 15 and 1 over 8. So that I was using those two here. Number of moles are 1 over 15 or 1 over 8, and then you're going to divide by volume to get concentration, divide by time to get the rate. So that if you divide 1 by 1, only remaining is K1, K2 and this numerical value. So you are getting K2 is greater than K1. See, K1 if you multiply by 1.8, you are getting K2. So it's K2 is greater than K1. When temperature increases, kinetic energy increases, collision increases. Temperature increases, number of molecules greater than activation energy increases. Orientation increases, effective collision increases, rate constant is greater. That's why K2 is greater. Anyway, whatever the way we can give the answer. Okay, question number 6, first part comes through this. No. Yeah. This part is I'm just writing to convince you guys. Not necessary to write this. This part is I'm just explaining to you guys. Then you know this, your answer is correct. Part B, enthalpy and entropy data of dissociation of weak acid HA are given. Question එක තිබ්බ නේද මතක? Yeah. This is the HA dissociation. See the normal HA dissociation, A minus and H plus, delta H1 here, delta S1 here. And then again they were given A minus gas to A minus aqueous, H plus gas to H plus aqueous, and HA gas to HA aqueous. These are the dissolution enthalpies. Balanced chemical equation for the dissociation of HA in gas phase. Okay, it's supposed to be exactly same as the liquid phase 1. Then calculate the following enthalpy, entropy and Gibbs free energy. Okay, so this is the equation. And then I'm going to go with one single. I am going with the blue. You can go the same or you can do another diagram. These blue values are enthalpy values. So the HA gas, H plus gas and A minus gas. Enthalpy change they want us to calculate. And then if you add water, they are making HA aqueous, H plus aqueous and A minus aqueous. But still, the diagram is not completed. To complete that, you guys need another data, HA aqueous dissociation to H plus and A minus. Clear that? Okay, so this is the full thermochemical cycle. Once we completed that, I'm going with enthalpy values with these blue numbers. The same way you can go with the entropy as well. I have gone with entropy values with these orange numbers. So this is the entropy values. So that only unknown is this delta H and delta S. So all the way from here and from here, two different parts are same. Subject delta H, enthalpy is 1151. Entropy is 3.195. Correct? Yeah. Online kids, make sure you are understanding this, okay? And then they want us to calculate Gibbs free energy. Gibbs free energy. Delta G equals delta H minus T delta S. Remember, they were not mentioning this standard condition. So that if they were written standard condition, you are not getting marks for this. No marks if you have gone with the standard condition. Do the substitution for 300 Kelvin. This is kilojoule and this is kilojoule, so no point of multiplying with 10 to the power 3 as normal calculations. So the Gibbs free energy value become 192.5. And see, this is greater than 0. So this is non-spontaneous. Non-spontaneous. And for the last part, part 4, at what temperature, for part 4, at what temperature the Gibbs energy change of dissociation of HA in gas phase for this one. So we can use this data. Become equal to its Gibbs energy change of dissociation in the aqueous phase. Okay, so this one is the gas phase. Aqueous phase we already calculated. But before that, calculate the Gibbs free energy change of the dissociation of HA in aqueous phase. To calculate that aqueous phase, I was showing you the very first data, and that is this one. Delta G equals delta H minus T delta S. This time they were given these both data. Delta H and T delta S, they were given these two data. Only temperature is separately we're going to substitute. You can get the answer. Delta G equals minus 27.5 kilojoules per mole. And let's say these two are equal. Delta G gas supposed to be equal to, මේ අපි disconnect කරලා connect කරගමු. හරියට වෙලාව ගන්නවා ඒක. මේකේ ඉඳින්න වෙන්නේ නැති. WhatsApp එකේ this is the last page. Delta G gas supposed to be equal to delta G aqueous, so that the delta H minus T delta S gas supposed to be equal to delta H minus T delta S aqueous, so that I'm going to get this T delta S into one single side and then subject temperature, and then you are coming to this point. So now all the data we found. So the gaseous phase we already found earlier, and the gaseous phase delta S we already found. These two are they were given as a data. Simplified, temperature is 97.96. So usually all your these calculation expressions are correct. Question number 7.
ராஞ்சி சேர்கிட்ட சொன்னிச்சான் அந்த குசுனி உடஞ்சிருச்சு அதுக்கு சல்லி அனுப்பணும்னு சல்லி அனுப்பணும்னு சொன்னிச்சா
மஞ்சுளா මංජුලා රෙකෝඩින් එකට කතා කරනවා ඇහෙනවා. Okay. This one. Using only the chemicals given here. So you have 3 carbon here. At the end of the day, you have another 3 carbon here and 3 carbon here. If they were given green art, this is easy. No, they were not given green art, but they were given sodium acetylide. You can go through the sodium acetylide. If it is sodium acetylide method, then we need alkyl halide and sodium acetylide. So anyway, we have to start from this one. Making the sodium acetylide is easier. So converting this is to C1C alcoholic KOH, and then C1C with C sodium with sodium. That part is done. Then the other side we have to make this one carbon alkyl halide, let's say this one, CC, that is this one, and then to this middle carbon, CC double one C. This part CC, you have a double bond here, this is supposed to come from this part, and then the other side you're going to go this middle carbon. To this middle carbon, you're going to join this halogen because it has to join with sodium. So that, keep that in your mind. I can start from here, CO, convert to OH. See, now it's the correct path. So bromine in the middle carbon. Then you are coming to here. Then remember the Lindler reagent, but you have to write everything. Hydrogen, palladium, barium sulfate, quinoline. Got it? Because? Oh. Really? Make sure. Oh. Yeah. No, no, no. You're going to get marks up to here and then from here. You are losing marks only to the part which you did mistakes. You are losing only that marks. So they can mark other marks. Anyway, so they were given all this like 4 marks for all those structures. 4 marks. Okay, there are a lot of different methods to get there. So the next one, synthesize compound B using compound A. Okay, 2 carbon to 4 carbon, 2 bromine. How easy? Okay, add PCC, CHO, one side, and then the other side I'm going to make, adding PCl3, I'm making the alkyl halide. Through that I'm making the Grignard. Okay, and then this is the Grignard part, and this is the carbonyl part, and then concastuoso4 here, and then at Br2, then you can join 2 bromine here. There are a lot of different methods to this one. Okay, part C. Do you guys want more time to go with the part B? Draw the structures of compound C and D in the reaction sequence given below. Okay, concastuoso4 to this one. Okay, what can you think? Concastuoso4, just concastuoso4, adding. That is the electrophilic addition, but since you have only concastuoso4, you have to stop from here. And then when you add water, you are coming to D. Add water, you are coming to D. Did it? You couldn't find a way. Forgotten? Yeah, seriously. And then explain the observation by taking in account the fact that H2O can act as a nucleophile. Yeah. So they want you to explain the mechanism then. See how many marks you guys are losing. Please make sure that. Okay. So that this is dissociating and double bond is attacking to this one 2 marks. Then that one is joining here, Markonikov, and then you're going to get the plus charge on this CH, and then again this water molecule is joining here, but then oxygen gets the plus mark, that is unstable, so that this hydrogen is getting away with its H2SO4 minus, then this is the final product. Okay, the explanation, when medium is diluted, number of H2O molecules is high. Also, electron donating power of H2O is greater compared to HSO4 minus. Therefore, H2O4 is a better nucleophile compared to HSO4 minus. Therefore, through an intermediate with H2O, alcohol can be obtained. based on the S and P block elements in the periodic table. Going to start එක ගන්නේ. Okay. White color solid. Maybe we can say that's coming through this group 1, 2, or D block these 1, 9 like scandium zinc whatsoever. Okay, let's keep it. And then who's giving? Okay, again white solid and gas. අපිට මේකේ මුකුත්ම ගන්න බෑ. Then Q with dill acid, it's releasing NO2. Releasing dill acid with NO2, releasing dill acid with HCl, and that is reddish brown color. So this is definitely supposed to be NO2. This can be either nitrate or nitrite, but then this is heating. You are heating this one. You are heating something to get this one. Then Q is supposed to be the nitrite. Then P is supposed to be nitrate. Moving on. And then we figured out this anionic part for cation. They say Q is reacting with ammonium chloride, whatever it is, bright yellow color flame test. Bright yellow flame test, that is definitely sodium. And then this is supposed to be sodium nitrate, sodium nitrite, then this is oxygen, sodium nitrite NO2, sodium nitrite ammonium chloride, sodium chloride ammonium nitrite. But when you heat it, you're going to get you're going to get this sodium chloride. And then this sodium chloride is the one white residue which is giving the yellow color to the flame test, plus nitrogen, that is a U, colorless gas. And then again they say it is releasing water vapor, so that is water. Figured out up to that. Then I'm moving on. This R is oxygen, and colorless gas V giving same U. What is this U? U is now nitrogen, so this is nitrogen. Okay, nitrogen and water vapor. To give nitrogen, V probably ammonia, අපි තම V දන්නේ නෑනේ. අපි V එක්ක යනවා, not sure. And then they say again, calcium plus U. Calcium plus U. මට V එක තාම නිකන් confirm නැහැ. Calcium plus nitrogen gives the calcium nitride. And then calcium nitride with water gives V. That is definitely what? Ammonia. Then this is ammonia, oxygen, nitrogen and H2O. It's done then. Then X is magnesium. So magnesium plus oxygen, magnesium oxide. Magnesium oxide plus water, magnesium hydroxide. How beautiful. How beautiful. And what would you need? You guys need memory. Need a memory. I'm going to give this question too. Question 8, 2014 to 2026. Okay, then answers are these. Proof එකද? බබා ගන්න අරගෙන යන්න. Okay. So every week like you can get here and get that. ඒ මල්ටි ගන්න අරගෙන ඉන්න. නැත්නම් ඔයා ගෙනියන්න කොට. Manjula. Okay, going to part B. 14 papers then, 14 away, 15. Okay. 1, 2, 3 were carried out with an aqueous solution containing an inorganic covalent compound Z. The test of observations are given here. Added an acidified suspension of manganese hydroxide to aqueous solution. Okay, they are adding this oxidizing agent, pale pink, supposed to come from the reduction of this one. Then some sort of reducing agent supposed to be here. Evolution of O2. O2 comes from what? Evolution of O2 very easily come from hydrogen peroxide. Then MnO2 is oxidizing, hydrogen peroxide is reducing. Remember the Mn2 plus is again pale pink. Pass H2S gas to the aqueous solution. Pale yellow. Turbidity, that is sulfur. Pass SO2 gas to the aqueous solution. Add excess SO2 and added barium chloride, that's barium sulfate. So that's very easy. See. H2O2 or H2O, oxidizing agent. H2O2, O2, reducing agent. Since O2 is releasing, that is a peroxide. Manganese has this pink color. H2S2 sulfur, this is the turbidity. SO2 oxidizes to SO4 2 minus, so that barium sulfate is there. So this is definitely H2O2. And then MnO2 H2O2 reaction to give MnSO4 pink color, or even this one is possible. Then H2S H2O2 reaction, SO2 H2O2, and H2O2 barium chloride reaction. Then they are asking other uses. Bleaching agent for paper, antiseptic, oxygen production, oxidizing agent, and then the special bonds are hydrogen bonds here. Hydrogen bonds. Okay. Moving to part C of question number 8. Flowing process was used to determine the thickness of a layer of chromium coated on one surface of the rectangular sheet of an inert material. Megalang and rectangle sheet a dilute acid was used to dissolve the chromium of square value square area rectangle sample is given. The resulting chromium 3 plus was oxidized with H2O8 peroxide sulfate in neutral medium. This reaction they were given, but it's not balanced, so you have to balance this equation. So to balance this equation, I'm using half reactions. So this is the balance equation. This is a balance equation. And then after removal of excess H2O2 minus, the solution was acidified and excess ferrous ammonium sulfate, the mass is given, was added. Okay, so the acid dissolve, add H2O2 minus, then acidify, and add excess ferrous sulfate, so that is reducing to Fe2 plus, and then to find out how much is remaining Fe2 plus in the medium, they were titrated it with the unreacted Fe3 plus was then titrated with CV of dichromate. Balance equation of Cr3 plus H2O2 minus, that is asking on, that is this one, you can give that. So the Cr3 plus is reacting with H2O2 minus. Let's see. Make a and then Fe3 plus and Cr2 also. So that remaining, once you make this reaction, Cr2O2 minus, it's not only with Fe2 plus, oh that's what I'm saying. It's not only with Fe2 plus, this one is also in the medium. So it's that part is also reacting here, see? Not only that initially added. So this is a reaction with Fe2 plus and dichromate. Okay, so that they are asking, calculate the thickness of the chromium Let's see. Molar mass of this, given this ferrous compound is 392. They were given the mass divided by molar mass is the number of moles, 7.9 in 10 power minus 3. So, in excess Fe2 plus, this excess Fe2 plus was reacted with titrated dichromate. බලන්න ඒගොල්ලන් අපිව confuse කරන්න මෙතන dichromate එකකුත් තියෙනවා initially මෙතන dichromate එකකුත් තියෙනවා ඒ දෙක දෙකක්. And then they were given the externally added dichromate and 6 times of that. See, externally added dichromate to Fe2 plus 1 to 6, so multiply with 6, so that remaining Fe2 plus is this. And so that the reacted amount, this is the total Fe2 plus and this is the remaining. So the difference is the reacted Fe2 plus. Reacted Fe2 plus. So that if you divide that by 6 again, then you are getting this dichromate amount. Then you are getting this dichromate amount. Okay. So that this is the dichromate came through the plate sample. But this has 2 chromium. So that you have to multiply that by 2. So this is the number of moles of chromium. But still, as a data, they were given this density of chromium is 7.2. I'm going to keep it. This is the thickness. If the thickness is Y, they were given these other 2 values. So this is the total volume. Then volume multiply density. See, the volume multiply density is the mass, so that you can calculate the mass. And that's supposed to be equal to this is the mass. The number of moles is mass divided by molar mass is the number of moles. And this number of moles is supposed to be equal to the number of moles here. If you equalize these two, only unknown is this pi. So you can find the thickness, 3.2 into 10 power minus. It's an easy question. So they are trying to confuse you guys with using this same, see the dichromate you formed and dichromate externally you were using for titration. Okay, question number 9. Okay, for our new syllabus after 2019, question number 10 is this one, but this is question number 9. I'm just going to read everything. I know you guys are having less memory for this question. Everybody's complaining only about this one. Even when you are reaching like, a couple of these students are reaching like 47, 48, but still they are complaining their memory of unit 14 is less. So try to memorize. Following questions are based on the extraction of iron using the blast furnace. Give the common name along with their chemical formulae of the iron and other raw materials used in the extraction of iron. Hematite, Fe2O3, magnetite, Fe3O4, siderite, FeCO3, limonite, FeOOH twice, and also you need coke plus limestone, calcium carbonate, or dolomite is also the accept. Discuss briefly the function of each of these raw materials, concept and everything. Coke. Coke heat to give carbon dioxide, liberating large amount of heat. This helps to maintain a very high temperature at the bottom of the blast furnace. Number 2. Form CO2 reacts with carbon to give carbon monoxide. This is the main reducing agent in the conversion of iron oxide to iron. CO2 plus carbon gives CO. Third step, production of FeO directly by carbon. FeO plus carbon gives iron and CO2. What is the use of calcium carbonate to make the slag? Used to remove impurities such as sand, silicate and aluminate as slag. Calcium carbonate, calcium oxide, silicon dioxide, these two are slags. This is called the slag. Or calcium oxide to calcium phosphate. Slag. Slag is obtained in the molten state It is less denser than the molten iron. This prevents atmospheric oxidation mainly due to the hot air blown at the bottom. So the bottom ion is saving from the atmospheric O2 with a slightly high denser. Okay. Write balanced chemical equations, stepwise conversion of iron O2 iron. So the equations. Write the name given in the molten iron formed at the bottom of the blast furnace. That is called pig iron. Pig iron. Pig iron. And the composition is iron, carbon 3 to 4, silicon, phosphorus, sulfur, manganese. All are trace amounts are present. Indicate the changes of composition required to convert to iron into steel. Briefly explain how you would that. Because we never done this. See, that's why I asked you guys not to do this question during the real exam. I am giving you this knowledge. You need for MCQs and for in case if they give structured essay. Because writing these answers for the first time, not thinking about like whatever we have done earlier, it's really difficult. Because either you are getting this practice, these questions for like, let's say from 2000 to whatever this year, and then still you have issues. So how about then you are writing answer for something you never practiced? That's really, really sort of impossible to reach 100 marks. Reduce carbon, first you have to reduce the carbon content, and then you have to remove manganese, zinc, phosphorus, and slag. And then add alloy elements. You need to add chromium and nickel because they are asking you to make this stainless steel. And then heat with air. You can just, you have to just write that. Okay, then calculate the carbon monoxide gas. They just say gas. We know the gas is carbon monoxide. In kilogram used in the stepwise conversion of iron, producing 2000 kilograms of iron. Okay, so if you add these equations, together, this is the steps to make iron. If you use these equations, there are 4 equations, and if you add these equations like this, if you multiply first equation by 2, if you multiply second equation by 2, third equation by 6, and if you add all these 3 together, you are coming to this equation directly, the connection between carbon monoxide and iron, and that is 3:2. So they say this is 2000. To convert it to grams, multiply with 10 to the power 3, divide by 56, multiply with to get number of carbon, divide by number of iron. So that answer become 1500 kilograms. Waste gas mixture. Carbon dioxide, CH4, volatile hydrocarbon, except CH4. Here it's written, okay? Carbon particles and carbon monoxide. The waste gas mixture that travels up and comes. This here. Gases, carbon dioxide, carbon monoxide, and nitrogen, but the predominant gas is nitrogen. Okay, to state 2 major carbon species found in each of these following: atmosphere carbon, CO2, CH4, volatile hydrocarbons, carbon particles, carbon monoxide; lithosphere, in Earth's crust, fossils, fossil fuel, mineral containing carbonates, graphites, coke, diamond, all those are. Hydrosphere, in water, carbon dioxide, aqueous or carbonic acid, carbonates, bicarbonates, any of those. State 5 natural processes that provide the removal of carbon species from the atmosphere. To remove carbon dioxide: photosynthesis, dissolution of CO2 in water, bacterial decomposition of organic matter, Explain how human activities increase the carbon content in atmosphere. Burning of fossil fuel, agriculture and livestock, production of hydrogenated hydrocarbon, and burning of firewoods. So CH4 coming from this agriculture and livestock. Responsible for state two global environmental issues that are caused. Okay. And how would you get back this carbon dioxide? Make it third part, second part of monkey. How would you get back carbon dioxide to environment, atmosphere? Removal of carbon dioxide, precipitation of plants and animals, anaerobic fermentation of ruminants, animals, CH4, natural combustion of carbon by volcanic eruptions, bacterial decomposition of organic matter, CO2 and CH4 both are coming. So removal and coming back this carbon dioxide to the environment. Two global environmental issues. Global warming, depletion of ozone layer, photochemical smoke. Very famous answers. Chemical species responsible: CO2, CH4, hydrocarbon and NO2, halogenated hydrocarbon, CFC, HFC, HCFC, all those. Write two detrimental effects caused each of these environmental issues state on global warming and human health. Global climate and human health. Global warming, shifts in rainfall pattern, rise in mean seawater level, melting of polar ice caps, frequent cyclones, desertification, droughts lasting long period, frequent heat waves. We had heat waves, remember, a couple of, April. Last April was the worst one. This year is not that bad. Last April, remember, these animals were dying. Frequent heat waves, drying of freshwater reservoirs, extinction of species, epidemic disease, increasing of global temperature. You can write any. Depletion of ozone layer, skin cancer, cataracts, respiratory disease, heat strokes. Heat strokes resulting in death. Photochemical smoke, you guys have all those experiences in your lifetime, in your small lifetime. Respiratory disease, eye irritation, visibility problems. Question number 10 again. So this becomes your question number 9, which you're supposed to do at the final exam, because you are not supposed to do this 10th question. If you are already planning to do the 10th question, it simply means your inorganic is very, very weaker. So make sure, you have 3-4 months is a big timing. So make sure that you guys are fighting for this. So decide during the last week, if you still feel inorganic is difficult, either unit 5 difficult or electro difficult, then you can go to the 10th question. I mean the unit 14 question. Otherwise, don't give these up. Okay, question number 10. Domestic bleaching agent. Here refers as a bleaching solution contains equal mole amount of sodium hypochlorite and Cl minus. ClO minus and Cl minus. The amount of CO2 gas liberated by the action of excess dilute acids. Okay, when you add any dilute acid, it's supposed to be releasing Cl2. That Cl2 determines the strength of this bleaching agent. That's called the available chlorine. And they were given this reaction. I guess that's not balanced. 2H plus Cl minus Cl2 plus H2O. Cl minus plus 2H plus Cl minus Cl2 plus H2O. No, they were given only this reaction, this one. They were given that. That's balanced. Generally, the available chlorine of the bleaching solution is expressed as the amount of CO2 gas liberated from 100 grams of bleaching agent. They were done this one to find the available chlorine. 25 cubic centimeter of that taken out and dilute to 250. And then they were taken again another 25 cubic centimeter out. And to acidify the medium, they were adding acetic acid. Reacting with chlorine, they were adding Ki. See, this is a reaction, CO2 minus I minus. And this formed I2. Then to find that, they were using thiosulfate. See, we have thiosulfate given. From that I2, from that Cl2, we can find that very easily. Balance equations are asking, this is they were given. And this Cl2 releasing from this one comes here. And then at the end of the day, if you add these two together, this is a reaction. And then this I2 is here reacting with thiosulfate. See, 1, 2 is 2, 1 is 2, 1 is 2. 1. Make a kind. So the answer is very easy. Thiosulfate Cv, half of that is I2Cv. Then I2ClO stoichiometric ratio is 1:1. I2ClO minus 1:1. So that is the same number of moles of ClO minus. That was in 25 cubic centimeter. But they were diluted it up to 250. So this is in 250. But then that ClO minus to Cl2 is exactly 1:1. 1:1. This is again 1:1. So that same ClO minus is as same Cl2 multiply with the molar mass to get the mass. But the initial mass is they were given 1.2. The density of the bleaching agent is given. Okay, so this is the density, this is the mass, so you can calculate the total mass. And then they were taken 30 grams, and this is the total mass of chlorine, and then percentage is 6.7. See, this is the chlorine was in the bleaching agent. But to get the percentage, we need initial total. They were given the density and also volume. We were taken 25. Then that is 30 grams if you multiply volume into density. So that is the total mass. The mass we were found is here. Did you do this now? You understood this now? Yeah, when you are like brainy, like understanding this, whatever is really easy. On a makeup, even today, they are maintaining this continuously. So make sure that you guys do this part nicely. See, මේ question එක අමාරු නෑනේ. ඉතින් මේක අතහැරලා තමයි කරන්නේ. හිතන්න even කලින් සර්ට් කියලා තිබ්බද මම දන්නේ නැහැ. 10 වෙනි එක කරන්න ඕන කියලා. I don't know what went wrong with them. Okay, write the ground state electron configurations of iron, and then the common or the main +2 +3 oxidation numbers. Aqueous ferrous sulfate reacted with excess KCl. Yellow octahedral is what? Yellow octahedral with cyanide and iron. That is potassium ferricyanide. That's supposed to be potassium ferricyanide. And they haven't said anything about this redox reaction. Then whatever you know, you're going to go with that. May first time may okay question ekak kaawe the very first time. There are no any other clue. Just it's yellow color and octahedral, cyanide and iron. Those are the only information. Potassium hexacyanidopherate 3. See how easily inorganic marks. And then IPAC naming 30% of aqueous nitric. Give the red brown. What is this red one? Okay, red one supposed to be, we know that potassium ferrocyanide. But the problem here is they are saying they are adding this some sort of a ligand here oxidation state of iron remains unchanged, and they are giving this whatever the formula without proper order. 2 potassium I'm just writing. Iron is just there I'm writing. Since we have C5, there's supposed to be 5CN5. Then the only remaining part is NO. Only remaining part is NO. And since this is K2, then this is supposed to have -2. Oxidation number haven't changed, +2. And then this is -5. To get -2 out, method -2 ne. So you're supposed to have another plus charge on this. So this NO cannot be this one. There are no charge. So NO supposed to be this one. So the entering one supposed to be NO plus. The one which is releasing out is one of the CN minus, because you have all CN here. Got it? Okay, go through these. Again, I would say this district for students ideas. My ideas now they are giving, because they were learning from us, so they are using the same tricks. So they said until you reach 100 out of 100, regardless how many times you do these papers, you have to do. Sometimes they do only 2 times or 3 times, because that is their level. But if you are okay with that, that's okay. But unless otherwise you cannot reach. Second time still, let's say you are reaching 45, third time you are reaching 49, then still you have to do another one more time, because you need 50 out of 50. That's how you're supposed to go on. Last little part coming from electro. If you go through these questions, even from now, 2012 onwards, see, continuously adding same sort of questions, then you are improving your knowledge. Water waste generated in an industrial process, pH is given, contains a color compound D. A treatment plan is designed to remove the color by electrochemical oxidizing this compound. Electrochemical oxidation of the compound D in the aqueous medium takes place as follows. They were given those two equations. D makes A2 plus, B and 2 electron, and then the water 2 electrons. So these two electrons are matching here. So that you can go with this stoichiometric ratio here is 2 electron matching here. So then this is 1 is 2, 2 is 2, 1 is to 1. Understood? This is 1 is to 2, but this is 1 is to 1. So then this one become again 1 is to 2. Okay. I have written that here, so I'm not gonna show it here now. And then concentration of the compound D in wastewater was found to be 0.001. Calculate the time required for complete electrochemical oxidation of compound D in 1 cubic decimeter sample of the wastewater by an electrolytic cell, considering 2 platinum electrodes are neutral, they are not participating, using a constant current. Current is also given 100 milliamp. Okay, so that if there is one single charge, how much current is it producing? 1 electron. So 1 charge ion, so the current it is releasing equals to the charge of the electron. 1 charge means 1 electron, that is the best example. If it is a per mole, that charge of the electron has to multiply the per mole value. That's how you are getting the Avogadro number. Sorry, Faraday constant. That's how you are getting the Faraday constant multiplying with the Avogadro number. If the charge is twice, here, this is make A2 plus, 2 charges, Then this value you have to multiply by 2. Okay, then keep that in your mind. So on. And in this waste poster, number of moles of D in 1 cubic decimeter, they were given as 0.001. But moles of electron producing by remaining by this equation, that if you go with the the questionnaire again, A2 plus 2 electron is 2. See, equation number 1, number of electrons are producing by that is 1 is to 2. So if it is releasing 0.001 D, twice of that electron is supposed to be releasing. So this is the total electron number of mole. See, if it is 2 charge, twice of Faraday constant. If it is 0.002 charge, so the amount of electricity or the charge needed is 0.002 multiplied the Avogadro number, the Faraday constant. Getting it? Okay, Faraday constant. So that this is the charge. Q equals IT, T equals Q over I. So that the total charge is, current is 193. And then the current is, they were given as this. Coulomb ampere, ampere second is Coulomb. This Coulomb equals ampere second. So you can cancel off ampere to ampere. Milliamp to ampere multiplied with 10 to the power minus 3. So that you can find the time. Either 1930 seconds or 32.17 minutes. This is always the style of electrochemistry. So even if you didn't do those tute, if you go through this path going from this chemistry to up to your paper, you can reach this exact same improvement. Part 2, if AOH is completely ionized in the aqueous medium, calculate the pH of the wastewater sample after the electrochemical oxidation. Initial pH is, this is 7. Okay. Okay, so per 1 mole of D, how much? Equation per 1 mole of D, 1 is to 1 ratio here, they are releasing 2 OH minus, using equations, okay? Using equations. Number of OH minus formed by 1 mole of D equals to 2. But we have D how much? 0.001. And then the total number of OH minus is twice of that. So that the total number of OH minus is 0.002. 1 is to 2 ratio, okay? So that this is the OH minus concentration, but initial volume is taken as 1 cubic decimeter. So this is the concentration. Get the minus log 10 of that. So that the POH equals 2.69. So that the pH equals 14 minus that 11.31. If you still feel uncomfortable with this part, I want you guys to go a couple of times because these are very beautiful questions and very straightforward answers. Go again repetitively. And then the last little part. If the above industry release wastewater containing compound D at rate of per second 10 cubic decimeter, calculate the minimum current that must be supplied to the electrolytic cell in order to completely oxidize D. Okay, now we know the timing. Amount of charge for 1 second of current, Q equals IT, I equals Q over T. Minimum current needed for 1 cubic decimeter of wastewater, we already found that 193. Because we have 0.001 into 2. We found the total amount here, the current, 0.002. That multiplied with the Avogadro number, this is the total current. Okay. So this is the minimum current, 193. And then that is per 1 cubic decimeter, but they say there are 10 cubic decimeter. Then total current for 10 cubic decimeter is supposed to be 1930. And then that divided by the timing, per second timing, is the charge. So this is the total current. And per second, it's that current comes with the per second. Ampere second is the coulomb, and then ampere second cancelling off. Then the ampere value is same, 1930 ampere. Could you guys understood this part? Yeah, this part, is it all? Yeah, that's all with this paper. So once you guys leave, just couple of students are coming here to write papers. For them, I'm just giving instructions, and I can watch them as well. But if you are not coming here, then I'm just doing how would you do 2015 paper? Not much difference. Actually, you are maintaining exact 2014. The reason is 2015 is again sort of the same. Once you move to 2016, 16, 17, 18, with those three papers, I'm gonna squeeze timing. Can I squeeze time in here? How much time you guys took to this paper? Huh? No, like only MCQs. Oh yeah, I guess you guys are there now. So that I'm gonna squeeze your time now from 2015 paper. Until 2018, we're gonna squeeze timing. And then 2019 onwards, I'm going to go with the normal again. Then 20 or 21, we're going to do a different path. It's again a different path. Okay, so we're done for the day. Bye, take care.